Auzubillahiminash-shaytanir-rajim. Bismillahir-Rahmanir-Rahim. Myself, Muhammad Usman Sajid, and I am the student of Mechatronics Department from Yale University in the fourth semester. Today, I will tell you about the brief discussion of logic gates, the verification of truth table of logic gates. So, here we have the logic gate of AND. So the circuit of this AND gate is we use two switches, switch A and B. Switch A is connected to the resistor and which is grounded, and also the switch connected to the input of 7408 ICs 1, and switch B is connected to the input of B. We can say input to two input. So basically it take two inputs and gave only one output. So switch B is connected to the input of 2, and also switch 2 is connected to the resistor of 330 ohm, which is grounded. So here the output is connected to the resistor 330 ohm, which is connected to the LED bulb, and then it is grounded. So and here we give the input voltage of 5 volt. Uh, sorry, here we give the input of 5 volt, and the verification of this truth table is of truth table of AND gate it that it gives its output 1, or we can say that bulb is on when each input is 1 or both switches are on. Otherwise, if any switch is off, then the output will be off, no bulb is on. So here we verify this. First we switch on the switch A, and we see the result. uh, no bulb is on, the output will be 0. Then we on the switch B, we see the result that no LED bulb is on, and output will be 0. Then we on the both switches A and B, and bulb is on. So this verify our AND gate. Next, this is our OR gate. The circuit of AND OR is almost same. The only difference is we have used IC is a 7432, and again switch A is connected to input 1 and switch B is connected to input 2, and switch A is connected to a resistor of 330 ohm, which is grounded, and similarly switch B is connected to a resistor of 330 ohm, which is grounded, and output is connected to a resistor of 330 ohm, which gives which output to the LED bulb, and then connected to the ground. So the verification of truth table of OR gate is that it gives its output 1, or we can say that bulb is on when any input is 1. The only in output is 0 when both the switches are 0. Here in this case, the both switches are off, or we can say 0 input, so the output will be 0. No bulb is on. If we give input A1, then output will be 1. So here we verify this. Uh, we give on, and bulb is on. So again we close all switches and we give input a input 1 on switch B, then bulb is on, and we give input 1 on both switch A and B, again bulb is on. So this verify our OR gate. So this is our third logic gate, which is NOT gate. NOT gate is basically an inverter which inverts the input. If our input is 1, then it gives output 0. If our input is 0, then it gives the output of 1. So the in the circuit diagram we have used only one switch, which is connected to the 330 ohm resistor, and which is grounded, and the input here we have one input and one output. The output is again connected to the 330 resistor, which is connected to the LED, and which is grounded. We also give the input of 5 volt here. Here we see that when the bulb is on, the we can say the input is 1, the output will be 0. Bulb is on, sorry, switch is on, the bulb is off. And when we off the switch, we can say we give the input 0, the output will be 1. Here we of the switch and run this simulation. The switch is off while the output is 1. Our bulb is on, and when the switch is on, the bulb is off. So this verify our NOT gate. Next we have the logic gate of NAND gate. NAND gate is basically the in, invert of AND gate. We can say that the complement of AND gate. So here the verification of truth table is that it gives us output 0 when both switches are on, or we can say that both inputs are 1 or both switches are on. Otherwise, if any switch is off, it gives the output 1. The circuit diagram for this is also same as AND gate and OR gate. The only difference is that we use the IC of 7400 here, and again the input supply is 5 volt. So here we will verify this. First we give the we can say we that both switches are off and output will be on, or we can say bulb is on, output is 1. When I close the switch A, again output will be 1 and the switch and bulb is on. When I close the switch B, the again bulb is on. When I both switch A and B give 1, then output will be 0. Here we will see this. So this verify our NAND gate. When both switches are on, the output will be 0. No bulb is on. So this verify our NAND gate. So next we have the logic gate of NOR. NOR is basically an inverter of output of OR gate. It basically invert the output of OR gate, or we can say that the complement of the output of OR gate. So the verification of that truth table of NOR gate is that it gives output 1 and bulb is on when both the inputs are off or the input are 0. So if any input is 1, then the bulb is off, or we can say that output will be 0. The circuit diagram for this is also same like AND OR and NAND gate. The only difference is that we use here the IC of 7402 and input supply is also same. So here we will verify this. We can say that both switches are off, or output is 0. The sorry, the input is 0, the output is on, the bulb is on. Here I give input of switch A1, and we will see that this bulb is off. Here we can see that I gave the input 1 on switch A, the output is going to be off. So now I will give input 1 on switch B, the again bulb is off. Here we can see. And when I give input 1 on both switch A and B, the bulb will still remains off. So this verify our truth table of NOR gate. When both switches are off, the only condition when bulb is on. Next we have the logic gate of XOR. It will give the output 1 when any switch is when we can say that it gives the output 1 when the both inputs are different. Like if one input is 1, another is 0, or if one input is 0, another is 1, then it will give the output 1. I will say if both inputs are 1 or both inputs are 0, then it will give the output 0. Here we can see that both inputs are 1, the output is 0, and when I give input A0, the switch is off, then the output will be on, we can say. And when I give out input to 0 on switch B, the again switch is the bulb is on. And when I turn off both switches, I will give input 0 on both switches, the again bulb is off. So the only way that the bulb is on is that both the inputs are different. Then the bulb is on. Otherwise, it will remain off. So this is our last logic gate, which is XNOR gate. The circuit diagram for XNOR is almost same. The only difference is that we have give the input supply of 5 volt on the output, and we have used the IC of 74266, and the verification of this XNOR gate is that it gives output 1 when both the input are same. For example, 0 0 or 1 1. When both input are same, then the output will be 1. Otherwise, if any input is different, switch A is 0, switch B is 1, or switch 1 is a 1, and switch B is 0, then output will be 0. So for giving the output 1, we need to both switch are on or off condition. So here we will see that both switches are on, or input is 1, the output is 1. When I turn off any switch, the output will be 0. For example, I give input 0 on switch A, or switch A will off, the output will off. Similarly, when I turn off the switch B, the output will also off. So when I both turn off the switches, switch A and B, or give input to A0, B0, then again the output will be uh, 1, or bulb is on. So when both switches are off or both switches are on, then this bulb will off. So this verify our XNOR gate. Hope you understand and you like it. Thank you very much.